Hey, this is Mrs. Ward reading Chapter 11, Section 1 of the chemistry textbook. Chapter 11 is about the mole. You're going to learn in this whole chapter about the mole and molar mass and making conversions, why it's important, and other things. I'm going to skip that and the Discovery Lab to get on to Section 11.1, Measuring Matter. The objectives of this chapter are to describe how a mole is used in chemistry, to relate a mole to common counting units, and to convert moles to a number of representative particles and a number of representative particles to moles. You're going to go both directions. So vocabulary is mole and Avogadro's number. Okay? If you were buying a bouquet of roses for a special occasion, you probably wouldn't ask for 12 or 24. You would ask for 1 or 2 dozen, especially if you were in the United States where things are sold in dozens. A dozen is 12 of any item. Okay, so eggs and roses and pencils are all sold in dozens in the United States. Similarly, you might buy a pair of gloves, right? 2 gloves. A ream of paper for your printer. This is a ream of paper here. Or a gross of pencils. Here's a gross of pencils. Each of the units shown in figure 11.1, a pair, a dozen, a gross, and a ream, represents a specific number of items. These units make counting objects easier. It's easier to buy and sell paper by the ream. A ream is 500 sheets of paper. It's easier to sell it by the ream than by an individual sheet. Counting particles. Each of the counting units shown in figure 11.1 is appropriate for certain kinds of objects depending primarily on their size and the use they serve. But regardless of the objects, boots, eggs, pencils, paper, the number that the unit represents is always constant. Okay? So we wouldn't want a ream of eggs. We don't need 500 eggs. We want a dozen eggs. We don't want a pair of paper. We would want a whole ream of paper, but a pair of shoes. Okay? So these these counting units help us count things, count particles, right? Chemists also need a convenient method for accurately counting the number of atoms, molecules, or formula units in a sample of any substance. As you know, atoms and molecules are extremely small. There are so many of them in even the smallest sample that it's impossible to actually count them. That's why chemists created their own counting unit called the mole. In the Discovery Lab, you found out that a mole of paper clips is an enormous number of items. What is a mole? The mole, commonly abbreviated MOL, is the SI base unit used to measure the amount of a substance. Remember, this is a counting, not a measuring unit, okay? It's for counting 1, 2, 3, 4, 5, okay? It is the number of representative particles, carbon atoms in exactly 12 grams of pure carbon-12. Okay, so there is 1 mole of carbon atoms in 12 grams of pure carbon-12. So they took 12 grams of pure carbon-12 and they counted scientifically how many atoms, and that number has become the mole. Okay? Through the years of experimentation, it has been established that a mole of anything contains 6.0221367 times 10 to the 23rd representative particles. Okay, that's how many atoms of carbon there are in 12 grams of pure carbon-12. A representative particle is any kind of particle such as an atom, a molecule, formula units, electrons, or ions. This big old number is called Avogadro's number. Avogadro's number, in honor of the Italian physicist and lawyer Amedeo Avogadro, who, in 1811, determined the volume of 1 mole of a gas. In this book, Avogadro's number will be rounded to 3 significant figures, 6.02 times 10 to the 23rd. Phew, that'll be easier to deal with. If you write out Avogadro's number, it looks like this. Check out all those zeros. Avogadro's number is an enormous number, as it must be in order to count extremely small particles. As you can imagine, Avogadro's number would not be convenient for measuring a quantity of marbles. Can you imagine having this many marbles? Avogadro's number of marbles would cover the surface of the Earth to a depth of more than 6 kilometers. But you can see in figure 11.2 that it is convenient to use the mole to measure substances. 1 mole quantities of 3 substances are shown, each with a different representative particle. The representative particle in a mole of water is the water molecule. Okay, so water molecules, 1 mole would be this many water molecules. So the representative particle in the mole of water is the water molecule. The representative particle in a mole of copper is a copper atom. And the representative particle in a mole of sodium chloride is the formula unit. So 1 of these formula units. Okay? I think what they're telling us is that this is a mole of copper and this is a mole of water and this is a mole of sodium chloride. Converting moles to particles and particles to moles. So this is going to be the mathematics part. Suppose you buy 3½ dozen roses. Remember, a dozen is 12, and you want to know how many roses you have. Recall what you've learned about conversion factors. You can multiply the known quantity, 3.5 dozen roses, by a conversion factor to express the quantity in units that you want, number of roses. You must set up your calculations as shown here so that all the units cancel except those required for the answer. So, the factor is 12 roses to 1 dozen. We want to know roses, so we have to make sure that the dozens are opposite each other, one on top, one on bottom. And we can flip this up or down, right? 12 roses to 1 dozen is the same as 1 dozen to 12 roses. So we can flip this upside down, however it works, depending on what we're starting with. So we're starting with a dozen, the dozen goes on bottom. Okay? We do our multiplication and we end up with 42 roses. Note that the units cancel and the answer tells you that 42 roses are in 3.5 dozen. Now, suppose you want to determine how many particles of sucrose are in 3.50 moles of sucrose. You know that, so 1 mole contains 6.02 times 10 to the 24 representative particles. Therefore, you can write the conversion factor, Avogadro's number, that relates to representative particles of moles to a substance. So, this many particles to a mole, right? Moles cancel out and we get this many particles. So if we're going to do it with sucrose, for sucrose, the representative particle is a molecule. So the number of molecules of sucrose is obtained by multiplying 3.50 molecules of sucrose by the conversion factor, Avogadro's number. Notice, sucrose is here, so sucrose is on the bottom. I'm sorry, moles are here, so moles are on the bottom. Molecules are on the top because that's what we want to find out is molecules, okay? So there are some practice problems. Now you want to find out how many moles are represented by a certain number of representative particles. You can use the inverse, okay? Again, if we want to find the number of moles, we have the number of representative particles over here. So we want that number to be on the bottom here. The number we're looking for goes on the top, okay? The number of moles of a substance is obtained by multiplying the number of particles by this factor, as you will see in example problem 11. I'm going to let you look at that. And that's the end of this section.